I hope everyone's doing well. I'm Mr. Rich. Thank you for joining me for this exercise video here. We're looking at first partial derivatives. You have here a function, we will call that z, where the x and the y variables pop up. You can do partial derivatives where you're holding one variable constant and you're differentiating with respect to the other variable. If you have an x and a y variable in an equation, you can hold one constant and do the differentiation on the other, and vice versa. Consider this terminology. You have this. What does this represent? Partial derivative. In this particular case, you are doing a derivative of a function. We are calling that z, but with respect to the x variable, but you will hold the y variable constant. Likewise, look at this representation where you are looking at a function z, differentiating with respect to the y, the x variable will be held constant. These are partial derivatives. You're looking at a z, a function having both the variables. You differentiate one, you hold the other constant. Your terminology in terms of your differentiations and your derivatives are right here. Here the x is being differentiated, here the y is being differentiated. The other variable in that equation will be treated as a constant. Now look at this in terms of examples, which is the best way to understand this. We have this function here z. It has x and y items show up. 2x squared minus 3xy plus 4y cubed. We want to evaluate this partial derivative, first partial derivative, because we're only looking at first order derivatives. But here the x variable is being differentiated, meaning the y will be held constant. Wherever you have an x variable pop up, you do its derivative using your basic rules of derivatives. 2x squared will become a 4x. The y is being treated as a constant, and a 3, you'll have a minus 3y. Because the derivative of x, standalone x, would be a 1. This is treated as a constant, it becomes a 0, and this here is your end result. If you're looking here at the first partial derivative, but now with respect to the y variable, the x being treated as a constant, when you do the derivative here, you know this is a constant, it will be a 0. Here you have an x and the 3, which are constants. The derivative of y is a 1. You'll have a minus 3x. And then the derivative of this would be a 12y squared. You can write this in a better way by just removing the 0, and your answer is exactly as you see. Look here at this other example. We have a function here z, and expression x squared over y plus y squared over x. Let's find the first partial derivative, and this is the terminology we're using with respect to the x. The x is being treated as a variable, we'll differentiate it, the y is a constant. When I'm looking over here, you know the y is a constant, you can look at it as this. And I'm just working here on the bottom. 1 over y, I have x squared. And then I have 1 over x, I have y squared. This is me rewriting this because now I'm looking at the x as my variables to be derived. X squared will become a 2x, but over y, because this right here is a constant. Now let's look at this. We can rewrite this part right here as y squared x to the power of minus 1. We'll have a minus x to the power of minus 2y squared. Now this is us doing the derivatives using our basic rules. The x is being derived, the y is being held as a constant. You just have to clean this out and you'll have your answer. You have here a 2x over y. Here you'll have a minus y squared over x squared. Me rewriting this using laws of exponents, and that should be correct. This right here is the first partial derivative of this expression or function z with regards to the x. Now let's look at the same expression but with regards to the y. Now we're going to hold the y as our variable to be derived. The x will be constant. When I'm looking at this, I can rewrite it as x squared y to the minus 1. Then here I'll have a y squared over x. Because x is a constant, it doesn't matter. We can even write it in a better way as 1 over x y squared. When you do the derivative over here, you know this is going to be our item to be derived using our rule. I'm going to have over here a minus x squared over y squared because the power will decrease by 1. Here I'll have plus 2y over x, and that should be a correct answer. So this right here is correct, that right here is correct. We've done the first partial derivatives of this function right here with regards to x and y as these items have been presented for you. Look over here, a certain function z is equal to sine 2x plus 3y. We have to find the first partial order derivatives, this, and we have to find with respect to the y, x and the y. In each case, then the corresponding item, the letter, the variable would be treated as a constant, the other one would be differentiated. Over here I'm looking at the x as my variable. How would we do this? You can bring in the chain rule. You can say u is equal to 2x plus 3y, but technically some people can do this in their head I'm just not skipping steps. Then function with regards to u is going to be sine u. You know the derivative of sine u is going to be a cosine u. Now do the derivative of the u, but you're treating here the x as your variable, y as your constant. When you're looking at the derivative of a constant, it's 0, but the derivative of 2x will be a 2. You'll have 2 come out. And this right here is your answer, but you'll resubstitute the u. When you do so, you'll have a 2 cosine 2x plus 3y, and it will be correct. I've used here the chain rule. It will be correct. Let's look at this case right here. Partial first order derivative with respect to the y variable. You can do again here the same item. Everything is the same. You're not changing anything, but now you're looking at the y as your variable, x is your constant. When you do it, the derivative of sine u is a cosine u. The derivative of this item right here with the y as your variable is a 3. The constant is a 0, and that's it. 3 cosine u, resubstitute it. You'll have a 3 cosine 2x plus 3y, and it should be correct. These are your answers. We close with this, because we're just looking here at first partial derivatives, basic technique practice. Z, a certain function is equal to e, exponent x squared plus xy. We're going to find the first partial derivative with respect to x, and then the first partial derivative with respect to y. Again, use the chain rule over here. If u is equal to x squared plus xy, then my function with regards to that u is equal to e to the u. Look here in the first case, I'm looking here at my x variable to be differentiated, the y variable to be held constant. When I look over here, the derivative of e to the u is e to the u, so we'll write e to the u. The derivative of x squared plus xy with regards to the x being derived will be what? You'll have a 2x plus y, because when you look over here, the derivative of x to the 1 is just equal to a 1. It combines with that y, the y is being treated as a constant, and this is what you have. But when you do your resubstitution, your end result should be 2x plus y, which I write first, and e to the power of your basic item, your u item, coming back e exponent x squared plus xy. It will be correct. Now look over here, the partial first order derivative with respect to the y variable. You're still looking at this, there's no changes over here. The derivative of e to the u is e to the u. That's what it is. Now look right here and do the derivative with respect to the y variable. The x is held as a constant. The derivative of x squared, which would be treated as a constant, would be a 0. Then the derivative of xy, where the x is a constant, y is your variable, would be just an x. When you resubstitute everything, you have x e to the power of u, but u is x squared plus xy, and this right here would be correct as well. Can we do something over here extra? If you want, you can, just for fun purposes. You know z is equal to e exponent x squared plus xy. Wherever I have an e exponent x squared plus xy, I can substitute those parts with a z, and I see them over here. When I look over here in the top part, I can rewrite my answer as this in a condensed form, though the answers presented are correct, times z, because this right here is equal to z, so I can bring a z. Likewise over here, I can just say xz, because I know this part is always equal to z. So you have a bunch of ways. Here's one and it's correct, here's one and it's correct. That's with regards to this. Then with regards to this, you have two items which you can present as an answer. This one right here and this one. They are all correct answers. And with this question right here, we close out this video. Just basic practice, first partial derivatives. Thank you.